let's talk about the inverse of the tangent function, also known as arctangent. So here I have pictured for you the tangent function, just the regular tangent function, and you'll see that it's got the same kind of problems that cosine and sine have, where it's not one-to-one. It does not pass the horizontal line test. So we need to restrict it so that way it does. It's convenient to restrict it from negative pi over 2 all the way to positive pi over 2, because that little chunk then would then pass the horizontal line test, and I could find the inverse of that one-to-one function. So let's talk about, like, on our unit circle here, that means that I don't want, so tangent is sine divided by cosine. So I don't want the sine divided by cosine to be the same number. I need to restrict that. So in quadrants 1 and quadrant 3, the sine divided by cosines, those would all be the exact same, right? This would be a positive divided by another positive for the sine divided by the cosine, and this would be a negative divided by a negative for the sine divided by the cosine. So that leaves us with a bunch of positive ratios then for tangent in both those quadrants. So it can't be quadrant 1 and it can't be quadrant 3 at the same time. So if we eliminate quadrant 3, and then the same kind of thing happens in quadrant 2 and quadrant 4, that all the sines here are positive and all the cosines here are negative. All the sines in this one are negative and all the cosines are positive. So these give me a bunch of negative tangents, and this also gives me a bunch of negative tangents. All students take calculus, right? So then all the ones that are in this quadrant, the tangent of all those angles is going to be the exact same as the tangent of all the ones in these angles. So we eliminate this one. Why? I don't know. It's just because it's the conventional one that they eliminate. So they make it very similar to how arcsine is, where it goes from negative pi over 2 all the way to positive pi over 2. So there is, in those two quadrants, there's no sine to cosine. That's what tangent is. There's no sine over the cosine that's repeated for tangent. Okay, which is what we want. We don't want the tangents to be repeating those y values. So not y values here. Y values here is what I'm referring to. Okay, in any case, there is one other, though, difference between tangent or arctangent and arcsine. So both of them do go from negative pi over 2 to positive pi over 2. But the problem is that tangent is actually undefined here and here. Undefined. So that's because the sine divided by the cosine on both of these, we would be dividing by 0. That's why we have these vertical asymptotes here and here. So that's why here I didn't write it's not less than or equal to. It's just in between negative pi over 2 and positive pi over 2. So for arctangent, it's going to be from defined between negative pi over 2 to positive pi over 2 for that range, but not including them. That's why I purposely put the parentheses there. So thinking about what the original tangent function had. The original tangent function, well, before, the domain, well, it was restricted for the tangent function, right? The domain would have been, oh, it can't be at pi over 2 or any pi thereafter that or before that. Well, I need to restrict it even further than that. So now I'm going to restrict it. I'm going to restrict it to from negative pi over 2 to positive pi over 2, but not including them because tangent of negative pi over 2 is undefined, and same thing with positive pi over 2. And that's going to become the range then of the arctangent. So thus that range is negative pi over 2 to positive pi over 2. And then the range on tangent, well, that went from negative infinity to positive infinity. It goes up and down long ways, right? This goes up and down forever. So then that becomes the domain for the arctangent. So let's try and calculate some of these. So find the exact value of the arctangent of 1. So what I'm thinking, where is the tangent of what angle equals 1? But it's got to be an angle that's between negative pi over 2 to positive pi over 2. So nothing here, nothing here. Oh, did you notice this is a positive one? All students take calculus. Hey, since I only have the options between negative pi over 2 to positive pi over 2, but not including those two angles, since those are my only options, and I've got a positive one for the tangent, it can't be in the fourth quadrant either. So we're talking about the first quadrant, meaning that, well, where is the sine divided by cosine going to be the number 1, the ratio of 1? Well, at pi over 4. So my reference angle here is at pi over 4 at 45 degrees. And then that angle there, since it's in the first quadrant, is also 45 degrees. So the arctangent of 1 is, in fact, pi over 4. Find the exact value of the arctangent of negative root 3. So I'm asking myself the question, tangent of what angle gives me a negative 3? You can think about that as a negative 3 to 1. But it's got to be somewhere between negative pi over 2 to positive pi over 2. Also known as negative pi over 2. Oh, yeah, that was a parenthesis there. Also known as in quadrant 1. Or in quadrant number 4 are our only options. So this one's out and this one's out. We're talking about arctangent. So I'm thinking, well, if this is a negative number, all students take calculus. Oh, it's got to be a negative number. It can't be in the first quadrant. Then we're talking about the fourth quadrant. So when I draw it in there, oh yeah, reference angle. What is that reference? Oh, that reference angle would have to be, well, where is the sine going to be a root 3? Or root 3 over 2, or what angle am I standing at so that the opposite is going to be a root 3? You're standing at the 60-degree angle, or at pi over 3. So if that's the case, then the arctangent of negative root 3, that angle, well, I can only go between negative pi over 2 to positive pi over 2. So this is going to have to be a negative pi over 3 in order for me to get there. Are you guys doing okay? Oh, wait. I can't hear you. That's actually it. So I hope that that made sense, and you guys can always ask for help for anything that you guys had trouble with. Best of luck. This is Mrs. Rainey, and I'm signing off.